All right, we're going to talk about T number 18, and that's the difference quotient. And remember, we talked about the word derivative in class yesterday. And derivative basically just means the slope at one point. So, and that's supposed to be point, y'all. So I don't want nobody saying, what is that? You know how Elizabeth get. I don't know what that is. That's point. But I was rushing. So the definition of the derivative, which is the slope at one point, and we're talking about at whatever x value equaling c. Now remember, we talked about two types of rates. We talked about average rate of change, and we talked about instantaneous rate of change. Now the average rate of change, we said, was when we had our graph, and we had 2 points that the line was going through, and we called that the secant line, right? And the slope of the secant line is basically the slope that we've always been dealing with. Let's just say that this is my function, and I know I have a point here. And see, since that x value is c, its y value is f of c. If this function is y equal f of x. And I have a point here at x, comma, f of x. Okay, so if I wanted to find the slope of the secant line, it's just a regular slope equation, right? M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Remember that equation from algebra, geometry, all your math classes, right? So I wanted to find that slope. I know that this has to be my x sub 2, y sub 2, and this is my x sub 1, y sub 1. It don't matter, but since this is the second point, on the function, it's the one furthest to the right, I'm going to call it x sub 2, y sub 2. So if that's the case, then y sub 2 is f of x minus y sub 1, which is f of c, and that's all over x sub 2, which is just x, and minus x sub 1, which is c. So this equation essentially would help me find the slope of the secant line between those 2 points. Well, instantaneous rate of change, remember last class period we talked about we wanted the instantaneous rate of change to be that derivative, the slope at one point, right? So what if point C and point X, well, point C comma f of C and X comma f of X were so close to each other that they ended up being the same point. I remember all up until now we've been talking about limits, right? So, and when we talked about limits, we talked about how some things approach another particular thing, and it gets so close, right? So I want these points to be so close to each other that they're basically the same point. Well, the only way I could do that is I have to look at the concept of the limit. So the meaning, the instantaneous rate of change of f of x with respect to x at x equals c. If I still I still have this same difference quotient, f of x minus f of c all over x minus c. But I want these values to be almost equal. So if they're almost equal, I'm going to end up getting that if f of x is basically almost equal to f of c, I mean that's close to 0, right? If x is close to c, then that's close to 0, right? So I want this to get close to 0. So that means I want the limit of x to approach. Well, if I want this to be 0, if I want those to be close to 0, then x minus what is going to give me 0? Well, I'm sorry, what minus c is going to give me 0 because I want to replace x with it. What minus c is going to give me 0, so x would have to approach c. So this limit here, this difference quotient, we call the derivative, all right? And we're going to say that this is equal to the derivative of f of x, and the way that we denote it is we say f prime of x, okay? So the derivative of f of x, whatever that function is, we know that this graph represented y equal f of x. So the slope of a tangent line, the instantaneous rate of change of f of x at some x value, we call it x equals c, we use this difference quotient. So we just derived the difference quotient. Now let's see how we use it. Okay. So it says use the definition of a derivative to find the value of f prime at c when c is equal to 5 and f of x is equal to x squared minus 8x plus c. Write the equation of the tangent line. So the first thing we need to do is find the derivative. All right, so that's finding f prime of x. So I know that f prime of x is equal to this particular equation here. So I need to find f of c. Y'all see that? Because that's in my equation. And so if this is f of x, f of c, and we said c was 5, so that's f of 5 would be 5 squared, which is 25, minus 8 times 5, which is 40, plus 18. So that's negative 15, 25 minus 40. That's a negative 15 plus 18. Negative 15 plus 18 is 3. So f of 5 is 3. So when I do my limit, the limit as x approaches, I want it to approach the c value. C is 5. So as x approaches c of f of x, f of x is x squared minus 8x plus 18. Then minus f of 5, which we said was 3. We're going to divide that by x minus the c value, which we know is 5. So I have this fraction here. So I can simplify the top. X squared minus 8x plus 18 minus 3. I know that's going to end up being 15. So that's the limit as x approaches 5. Notice I'm writing my limit. You don't quit writing until you plug in. I get x squared minus 8x now plus 15 all over x minus 5. Now, y'all know with the limit, we say we always plug in first. If I plug in 5 for x, 25 at the top minus 40, so negative 15 plus 15, I'll get 0 at the top. And of course, plugging in 5 for x here, I'm going to get 0 at the bottom. Indeterminate situation, so I mean factor and cancel. Right? Limit as x approaches 5. I'm factoring that quadratic at the top, so that's 2 parentheses with x. Two numbers that multiply to give me a positive 15, but add to each other to give me a negative 8. That's negative 3 and negative 5. So I have x minus 3 times x minus 5 over x minus 5. Boom, the x minus 5's cancel out. I'm left with the limit as x approaches 5 of x minus 3. Now I could just plug in. That's going to end up being 5 minus 3. 5 minus 3 is 2. So what does that 2 mean? Well, that means that on this graph, f of x equal x squared minus 8x plus 18, at the x value 5, the tangent line that touches that graph of x squared minus 8x plus 18 has a slope of 2. That's what it means. So now, if they want me to write the equation of the line, I know I have a point at 5, 3. That's the point on the graph. And I have a slope of m equal 2. So going back to geometry, when you talked about the point slope form, y sub 1, y minus y sub 1 equals m times the quantity x minus x sub 1. If you don't remember that, that is the point slope form. Y'all know about the slope intercept form and all that good stuff, but this is the point slope form. And if I want to write the equation of my line using the point slope form, remember we know our point is 5, 3, and our slope is 2. So if I want to plug in to my equation, I need to know that the point is the x sub 1, y sub 1, and my slope is m, so this becomes y minus the y sub 1, which is 3, equals the slope, which is 2, open parentheses, x minus the x sub 1, which is 5. So this is the line written in point slope form. The Cal test will take this, but you might have answer choices if you're doing a test that are in point in the slope intercept form. So that means I'm just solving for y. So I want to simplify this side. Y minus 3 equals, putting the 2 in. I know this would be my answer if this was, well, I'm just writing my answer, but if I'm looking at a multiple choice, I can simplify. So it's be 2x minus 10, and then I'm going to add 3 to both sides. Some of y'all might have to show it, so I'm going to show it. So y equals 2x minus 7. So the line y equals 2x minus 7 touches that graph at that point, 5, 3. So I'm going to let y'all do the other example by yourself. If you just follow these instructions, you'll be able to do it.